So now let's go ahead and use those properties of logarithms to do example 1. So in example 1, they're asking us to find the exact value for each of these expressions. Let's check out part A. We have log base 2 of 2 to the negative 13th power. One way of doing this problem is to scan through all 7 of those properties from the top of the handout and find the one property that is going to be applicable here. Notice the base of the log is 2, the base of the exponential is also 2. That means that property 3 could be the property that you use to do this problem. So if you want to use property 3, feel free. However, when I look at this problem, I simply think about it as a direct application of the property of logs from section 6.4. So that's how I'm going to describe this problem. Log base 2 is saying, hey, what's the power on your 2? Power on my 2 is negative 13. So negative 13 is my answer. Problem B is in fact the same kind of problem. Once again, you can think about it as a property 3 problem if you want to. I'm going to simply think about it as a section 6.4 problem. So natural log, remember that that is going to be then log base e. So log base e of e to the square root of 2. Log base e is saying, what's the power on your e? The power on my e is square root of 2. So the answer for part B is square root of 2. Now we're ready for part C. For part C, we have log base 8 of 16 minus log base 8 of 2. Now sometimes people look at this problem and they start by trying to evaluate log base 8 of 16. But if you try to do that, finding a power for 8 that gives us a 16, well, that's not an easy thing to do. There's not a nice integer power of 8 that gives us 16 back. So there must be a different way of doing this problem that allows me to use a property of logs, and it allows me to get my answer a little bit easier. Because they told me in this problem that I should always be able to find an exact value for these. So let's figure out then some way of doing this problem using one of our properties. So notice here we have a log guy minus another log guy. Well, if you think about all of our properties, we had a rule that did just that. Log guy minus log guy, we had property 6 that accomplished that. So when you look at property 6, we talked about it earlier and I described it in terms of starting at the left and going to the right, but all of these properties work both directions. So we can also start at the right and move to the left. So this particular piece is in fact the same as the right-hand side of property 6. So every time I have a log guy minus a log guy, I can always rewrite that as an equivalent division piece. But remember the warning I gave you earlier. You need to make sure then that when you're doing this kind of problem, that you have the right number of LOGs on each one of those sides. So when it's written as a subtraction, we have to have 2 copies of that log base 8. But when I write it as the equivalent division, I only write down that log base 8 once. So it's going to be log base 8 of 16, then we have the 2, so we divide that by 2. So it's log base 8 of the division problem, 16 divided by 2. I'm going to say it one more time just to make sure that you caught this. I had 2 copies of the LOG when it was written as a subtraction, but I only have 1 copy of it when it's written in terms of the division. So always be careful about that. Well, let's keep going. 16 divided by 2, that's an easy division. 16 divided by 2 is 8. So I have log base 8 of 8. Now that I have this then, log base 8 of 8, once again, if you want to, you can go ahead and think about this as a property. Property number 2 is going to tell us how to do this problem, but I can also simply think about it in terms of the definition. Log base 8 is saying, what's the power on your 8? What's the power on my 8? It's a 1. So the answer on this problem is the number 1. And then finally, as we look at part D, we have 3 to the log base 3 of 5. Well, as you look at this problem, it is set up exactly the same as property 4, so you can simply think about it as a property 4 problem. Property 4 then tells you, oh, write down the 5. So, yeah, we could do that. We could go ahead and say, okay, we're going to write down the 5. But remember the technique we used in order to develop that particular rule. If you have 3 to a power, an exponential function, and log base 3 with the same base, those are inverse functions, and they're going to undo each other. So 3 to the power, long base 3, they're going to undo each other, and the only thing that's left then is that number 5. So instead of memorizing property 4, I would always simply think about it as the inverse world. The inverses undo each other, and you are left with that number 5.